am Moses Oluwasegun Alex. You are welcome back to my YouTube channel. In the last video, I explained the cofactors of a given matrix, and I said I'll be discussing the adjoint of the matrix in another separate video. So in this video, I'll be looking at the adjoint of a matrix, the adjoint of a matrix. Okay, now by adjoint of a matrix, it simply means the transpose of the cofactor matrix. Adjoint of a matrix, okay, is the transpose of the matrix of the cofactors. So which means that before you can find the adjoint of any given matrix, you must have gotten the matrix of the cofactors. So once you get the cofactors, then the matrix of the cofactors, we simply transpose it. Now the adjoint of matrix A can be written as in a short form as ADJ bracket A. So the A represents the matrix A. So this is simply saying cofactor matrix, okay, transposed, so which is C transpose. So if you have the cofactor matrix and you need to find the adjoint of such a matrix, all you just need to do is transpose the cofactor matrix. And remember, when you say transpose of the matrix, you mean the exchange of rows for columns. All right. So as an example, let's assume we want to find the adjoint. Okay, find the adjoint of matrix B. Matrix B is the matrix 4, -3, -8, 9. So we want to find the adjoint of this matrix B. Now, to do that, first remember we follow the definition for the cofactor. So matrix B is the matrix 4, -3, -8, 9. So if you have to find the cofactor, remember the formula Cij is -1 raised to the power I plus j Mij. Okay, so since this one here is a 2 by 2 matrix, we can simply follow the sign convention. The first is plus, the second is minus, the second row minus, and then this is plus. All right. So if I'm taking C11 now, C11 means the cofactor corresponding to element 4. That's the one on the first row, first column. Okay, so C11, the sign convention is positive, that's plus. So first row gone, first column gone, so we're left with 9. Okay, so this one is simply saying C11 is equal to M, that's plus M11, and that is plus 9, which is sitting as 9. Then C12, first row, second column. The sign convention is minus. So this is minus M12. M12 means first row, second column. First row, second column. So we are left with -8. So this minus 8, and that is 8. Then C21. C21 is the sign convention. Second row, first column. The sign convention there is minus. So this is minus M21. Okay, so this is minus. Now what's M21? Second row, first column deleted. Second row, first column, we delete this. So we're left with -3. So this is -3 here, and this will give us 3. Okay, then the last one is C22. C22 is the second row, second column. The sign convention is plus. So M22. So plus M22, second row, second column. Okay, we delete that. Second row, second column, delete that. So we're left with 4. So this is plus 4. So the matrix of the cofactor C is therefore C11 9, C12 8, C21 is 3, and C22 is 4. And therefore the corresponding adjoint of that matrix B, okay, the corresponding adjoint of matrix B in that case would therefore be ADJC is equal to, that's the transpose of C transpose. So we transpose that matrix there. Row 1 becomes column 1. So this is 9, 8. And row 2 becomes column 2, 3, 4. Okay, so this is how we find the adjoint of any given matrix. So if the matrix you are given also is a 3 by 3 matrix, okay, we follow the same order to solve or to obtain the adjoint of the matrix. So if we are to pick another example, let's assume that we want to find the adjoint of this matrix. We want to find the adjoint of matrix P. Matrix P is the matrix 1, minus 3, 8, 4, 2, 5, 6, 1, 0. Okay, so we want to find the adjoint of this matrix P. So the same thing, the first thing we need to do here is finding the cofactor of matrix P, the matrix of the cofactors. So P is 1, minus 3, 8, 4, 2, 5, 6, 1, 0. So in that case, to find the cofactors, remember the definition. So we're not going outside the definition. We still follow the definition strictly. So we're looking for C11, C12, C13, C21, C22, C23, C31, C32, C33. So these are the different cofactors we need to find. So you can pause the video also and try your hands on this to get the cofactors. So for the first one here, C11, the sign is going to be positive. So this is plus M11, 1 and 2 negative, M12, 1, 3, that is positive, M13, 2, 1 minus, M21, 2, 2 plus, M22, 2, 3 minus, M23, 3, 1 positive, M31, 3, 2 negative, M32, 3, 3 positive, M33. Okay, so now all we need is to get the minor. For M11, M11 means first row, first column. We are left with 2, 5, 1, 0. The determinant of that, 2 times 0 is 0, 1 times 5 is 5, 0 minus 5, that's minus 5. So this one is minus 5. Okay, then M12. M12 means first row, second column. Delete first row and the second column. So we'll be left with 4, 5, 6, 0. 4 times 0 is 0. 6 times 5 is 30. 0 minus 30 is minus 30. So this is minus 30, and that is 30 here. Then for M13, first row, third column. First row, third column, we have 4, 2, 6, 1. 4 times 1 is 4, minus 6 times 2 is 12. 4 minus 12 is minus 8. So this is minus 8. Okay, then we'll move on to C21, which is M21 here. M21 is second row, first column. Delete second row and first column. So we have minus 3, 8, 1, 0. Minus 3 times 0 is 0. 1 times 8 is 8. So 0 minus 8 is minus 8. So this is minus 8. So this is 8. Then M22. M22 means second row, okay, second column. Second row, second column. So you have 1, 8, 6, 0. 1 times 0 is 0. 6 times 8 is 48. 0 minus 48 is minus 48. So this one is minus 48. Then M23. That is second row, third column. Second row, third column. 1 minus 3, 6, 1. 1 times 1 is 1. 6 times minus 3 is minus 18. So we have 1 minus minus 18. Okay, 1 minus 18, that is plus 19. So this is minus 19 down here. Okay, plus 9. M23 is 19. So because of this minus, so this is going to be negative there. Then M31. 31 is third row, first column. Third row, first column. So this is minus 3 times 5, that's minus 15. Minus 15 minus 2 times 8 is 16. So minus 15 minus 16, that's minus 31. So that minus 31. And then M32, third row, second column. Third row, second column. 1, 8, 4, 5. So 1 times 5, that's 5. Minus 4 times 8 is 32. 5 minus 32 is minus 27. So this is minus bracket minus 27, which is 27. Then the last one is the M33. Okay, row 3, third row, third column. 1, 2, minus 3, and 4. So 1 times 2 is 2, minus 4 times minus 3 is minus 12. 2 minus minus 12 is 14. So this is plus 14. Okay, so now we can write out the matrix of the cofactors. So the matrix of the cofactors is just putting the cofactors together in a matrix. So C will therefore be equal to minus 5 for C11. C12 is 30. C13 is minus 8. C21 is 8. C22 is minus 48. C23 is minus 19. C31 is minus 31. C32 is 27. C33 is 14. So the corresponding adjoint of the matrix, therefore, adjoint of matrix P, okay, adjoint of matrix P in that case, okay, simply means the transpose of this, and that is minus 5, 30, minus 18, 8, minus 48, minus 19, minus 3, 31, 27, and 14. Okay, so the first row will become the first column, the second row becomes the second column, the third row becomes the third column. So in this case here, the adjoint of the matrix is this. Okay, so this is how adjoint of a matrix is obtained. So please, if this is your first time coming in contact with this YouTube channel, please subscribe, like the videos, and at the same time recommend the videos, okay, to everyone around you, so that we can reach a very large audience, okay, and at the same time help them with their issues with mathematics. All right, so in the next video I'll be talking about inverse of a matrix. Okay, now we have known how to find the determinant of a matrix. We have seen how to find the cofactors of a matrix. We have seen how to find the adjoint of a matrix. These three are combined together to give us the inverse of a matrix. So in the next video, I'll be talking about inverse of a matrix, after which we can then look at solving systems of equation using matrix method. So let's see in the next video.